Now we're going to talk about elastic collisions, and remember in these there's no deformation of the colliding objects and there's no change in kinetic energy of the system. So the two basic equations must hold for all elastic collisions. We know that the sum of the momentum before should be equal to the sum of momentum after, so there is conservation of momentum, and then there is also kinetic energy conservation. So if you figure out the kinetic energy before and after, it should also be the same. You have a 500 gram cart. It's moving at 2 meters per second on an air track. It elastically strikes a 1,000 gram cart at rest. What are the resulting velocities of the two carts? So we want to know how fast are the two carts moving. This one's a little bit more involved. We're going to start by saying that the sum of the momentum before should be equal to the sum of the momentum after. We can then go ahead and say the mass of the first object times the first object speed before plus the mass of the second object times the second object speed before should equal the mass of the first object times the first object speed after plus the mass of the second times the speed of the second after. We know that before the collision this term is 0. Here we've got 0.5 times 2. And that should be equal to 0.5 times v1a, and that's the speed of the first object, plus v2a. Notice that we're going to have two unknowns in this problem. If we go through and solve, we end up with 1 is equal to 0.5. This time we're going to call v1a x, and we're going to call v2a y. We can do the same thing for kinetic energy. Let's first go through and just plug everything in here. We've got the sum of the kinetic energy for B, or before, should be equal to the sum of the kinetic energy after. That would be 1/2 m1 vb v1b squared. So this is the mass of the first times the speed of the first object before the collision squared, plus 1/2 times the mass of the second, velocity of the second before squared, and that should be equal to 1/2 times the mass of the first times the speed of the first object after squared, plus 1/2 of the mass of the second times the speed of the second after squared. You'll notice that all of our halves will cross off, so we don't have to worry about those anymore. We know this speed originally was 0. At this point we can go ahead and plug some numbers in. This would be 0.5, and we can multiply that times 2 squared. That would be equal to 0.5 times v1a squared plus v2a squared. Once again, we can go through, and instead of using the v1 and v2 we can use x and y. So 1/2 of 2 squared is equal to 2. That's equal to 0.5 times x squared. Okay, so that would be our a term, plus y squared. At this point we can go through and solve the two equations for our variables, for both x and y. So when we do that, we can just say we want to solve, and we know that 1 is equal to 0.5x plus y, and we know that 2 is equal to 0.5x squared plus y squared, and we want to solve those for x. If you do that, solution number 1 for the first object in the x and the y direction, because remember when they do this, you should get negative 2/3 and 4/3 meters per second. And the solution for number 2, xy, for x and y, you'll get 2, 0 meters per second. I know that's a little bit confusing, but that would be the resulting velocities in the x and the y direction for each one of the objects.